Hello everyone, welcome to Faangtastic Solutions. So today we'll be solving one Leetcode medium problem, which is named as container with most water. And this is pretty good question, which is being asked in almost all good companies most of the times. Facebook, Google, Amazon, Apple, if you see Microsoft, everyone is asking this question. So let's go through the problem statement and see how we can solve this. So the problem statement says you're given an integer array of height of length n. So this is an input, integer array which has been given to us. It asks there are n vertical lines drawn such that two endpoints of the ith lines are I comma 0 and I comma height of I. We need to find the two lines that together with x-axis form a container such that the container contains the most of the water. Okay. And now we need to return the maximum amount of the water the container can store. So that's basically we need to return in the area of that. So if we quickly try to see, let's say if this is one of the first index and this is the second endpoint. So between these two, how much maximum, water can be stored between this and this. So this can store this amount of water if you see. So the maximum amount of water could be what? Area would be nothing but length into width. So width would be what? If you see this is 1 because this is the index at 1 and this is the index number at 0, right? So 1 minus 0, the width would be 1 and length would be what? So the height of this container and this container. But if we go outside, like if we try to get this height, so the moment we go, whatever the minimum of these two height are there, right? The water will overflow. So any above water out of this, this area 1 will overflow. So that's how the length would be 1 and the width would be again 1. So that would be the total area would be 1 only. But if you try to see between this one and this one, the second and third, the height, how much water can be stored. So the width would be again 1. And what about the length? Length would be again, you can see the minimum of these two, right? Because the moment the water is going out of whatever the height we have this for the second index, this will overflow, right? So this height is nothing but 6. So 6 into 1. So the amount of water can be stored is 6. So that's how we need to find the maximum amount of the water can be stored. So one of the thing like which we can think of can let's be like whatever the two maximum the height which we have between them, can it be that answer? So let's say if this is an 8 and this is an 8, right? Both of them are 8. So height would be 8. What about this width? So width would be 1, 2, 3, 4, 5, right? So 8 into 5, if we can see we are getting answer as 40. So this can be a good candidate, like one of the largest candidate, but not the largest. And this can help to being one of the largest, but it may or may not be the largest. Now the answer, if you see between this 8 and the last candidate, which is 7, so the height would be the minimum of this 7 and 8, which is nothing but the 7, and the width would be 1, 2, 3, 4, 5, 6, 7. So 7 into 7 would be 49. So in some of the scenario, if you're thinking like whatever the highest candidate if we can find, and then the distance between two, they might contain the maximum amount, but that might not be always the case. So there are two factors which are going to increase our area. One would be, let's say, this width, like whatever the maximum width we can create. So that would be one of the thing which can help us to have the maximum amount of water, as well as the second will be the height, the minimum height between these two containers, like whatever the container we are going to form between these two heights, right? If they are going to form one of the container, so the minimum of two would basically decide the actual height which is going to be used to get the area. So the whatever the minimum of these two height, if we can create it as like keep it as a maximum, right? So both of them should be dependent on. So our end goal should be keep the width as far as possible, as well as height as a high as possible. Then that can help. So the brute force approach would be like start from the first index and then find all the area, and then out of that the maximum area can be given as an answer. Like you start from the 1, then 1 between 1 and 8, what is the area? 1 and then 6, what is the area? 1 and 2, what is the area it's coming? And whatever the maximum is coming, we can just replicate that. That could be one of the thing. The second thing could be, let's say we want to keep the width and length, the maximum. So we know we can start from this far end and this far end. Then we know that our width is maximum. And now our goal should be, to find the maximum area by shrinking one by one of them, right? The pointer one by one, and then try to find the maximum area. That can also help into the big one. So let's try to see how this can be done into the bigger picture. So this is how if you see our the given input array looks like. So now let's try to see like what we can do, like how we can start the pointers and all. So at the initial point of the time, our pointer is, let's say if we have two pointer I here and j here, right? So we know that our width is maximum, right? So what would be the width? Width would be nothing but j minus I, right? So jth index is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So j would be 8 minus 0. So that is our total number of width. Whatever the height or length we say, so length or height would be the minimum of this one and this one. So minimum of 7 comma 1 would be 1, right? So our area would be 8 only. 8 into 1 would be 8, right? So that's our goal. So we can have one variable, let's say the max area, and now we can initialize using 0. And now at this pointer, I is at the first and j at the index end. So now our area, the current area is coming nothing but 8 into 1, right? So can we go, and our goal should be the moment we find the area which is maximum, then the maximum area, just go ahead and replace with that. So now the maximum area would be this one, right? Now our next goals should be either move I inwards or j inwards, right? One of them should be move inward, right? And we need to know like which one, if we move inward, our goal should be to get the area should be maximized. That's the only goal. Anytime we are going to move something inward, make sure our area is going to be up. If we can keep the area as high as possible, then only move them inside. So to visualize this, let's see how which one is going to help, like moving I or j. So let's say, so one of them, so this array is not sorted, right? So either I can be smaller element or j can be smaller element, right? So let's say if in this current scenario, we know that I is smaller and j is the larger element, right? So either move the smaller inwards or the larger inwards. That's our end goal to find out, right? So let's try to find, in one scenario, move the smaller element inward, right? So that means the ith element. It can be I or j, whichever the value is I is the smaller, we are going to move them inward, right? So the currently the current number of the smaller element is nothing but 1, right? And now the area which we got was what? 1. And so how this area, how did we decide this one? So basically to decide 1, we checked the minimum of the ith element, which is 1, and minimum of jth element, which was 8, right? So minimum of 1 comma 8 is going to return us 1. And then now our width was at the largest width we found it, right? So width was 8. Now if you're going to shrink the I inwards, right? So there can be two scenarios, right? Either I is going to be like increasing or I is going to be decreasing, right? And what about the width? Width is always going to be decreasing, right? So we know that the moment we are going to move either smaller candidate or the larger candidate, width is going to decrease for sure. That is, let's say, in our area, we had the height and width, or length and width, right? So width is always going to decrease, right? So now the only deciding factor for us would be, which value we are going to shrink, right? So decide like whether we need to shrink the smaller value or the larger value. That's our end goal now. So we know that always we are going to decrease the width. So, but which one to decrease, like the larger value or the smaller value? So now in the first scenario, we are going to move, the smaller value inwards and try to find how can we keep the area as max as possible. So now the current value of I is 1 in that index, which is the smaller one. And now if you're going to move it inward, And let's just, for example, let's keep it as a 2. So that we can have the two scenarios. So let's say at the ith index the value is 2 for us, right? So area would be how much? In this scenario, area would be minimum of 2 comma 8, right? Minimum of 2 comma 8 would be how much? It's 2, and then would be the width was this one, 8, right? So 2 into 8 is 16. If you're keeping, let's say, I is at 2. Now if you're going to move I inward, right? So the first case would be if I is going to increase. So what if I is going to increase? Let's say the I was 2 and then it's getting increased to, let's say, exact double, which is nothing but a 4, right? So what would be the area, new area for us now? So if I is going to increase, then height would be for us what? It should be min of 4 comma, we didn't increase the j was 7, right? So min of 4 comma 7 would be 4, and the width is going to decrease, right? Width is going to decrease from 8, it's going to decrease to 7, right? So our area would be 4 into 7, which is nothing but 28. What happened? What was our previous area? Our previous area was 16, right? So now we know that our area got increased. So if you're moving a smaller element inward, then our area is going to be increased if the value of I is increasing, right? So we know that the area, one of the chances can be if you're moving the smaller value inward, then area is going to increase, which is a good case. Now the second case, if you're going to move the smaller value inward, right, then what if I is decreasing? So initial I was how much? We decided to make it as a 2, right? Now what if the I is going to be decreased? If I is, so even if I is decreasing, now we know that if the area is going like smaller value, we are moving down, there is chances that this area might increase, right? But let's think about this scenario as well. What will be the case? Now the value is going to be from 2 to 1, right? So the min of 1 comma 7 was how much? 1 into, then our width is 7, right? Because now we are coming from 1 and we are just assuming instead of 8 we are finding here 1, right? So 1 into 7 would be 7, right? And if we had a I as a 2, then our area was 16. So now the area got decreased. So now we have a decrease in area, right? But we know that if we are going to you know move the I value inward, and if there is a chance that the value of I is increasing, then the chances of the maximum area, like our area, might go ahead and increase it, and in some scenario it will decrease it. But what about the jth index, jth, or the larger value, if we are going to move it downwards, right? So just assume, let's keep the example same, like I is 1 and j as the 7, right? So our I was 1 and j was 7, right? This is j. Then what about the area? Area would be min of 1 comma 7 into our actual width, which was 8. So min of 1 comma 7, even though our value of j is 7, this is not, we are going to ignore it, and we are going to pick whatever the smaller value was there, right? So we don't care what is, if for the larger value, right, we don't care it at all, and our actual area was 8. So now let's try to move the larger value inward. So what if the larger value we are going to move inward, if the j is going to increase, right? So if the original value of j was 7, right, if you're going to increase it, let's say 10, then what is going to happen? So min of 1 comma 10 into our width is going to be decreased by 1, right? So now again, we know that, for the larger value, we don't consider into our height, right? So even though this value is going to increase, we don't care it at all. Our minimum value would always be the whatever the smaller value was there, right? And now our area is going to be decreased. So previously it was 8, now it's going to be 7. So even if you're moving the larger value inward, and if the value is increasing, that is not going to help. But what if it's going to decrease? So what if it's going to be decreased from, let's say, 7 to 3 or something, right? Or half of something, right? So min of 1 comma 3 into 7, right? So which is b, again, even if it got decrease, the actual value which was the minimum into 7 only, like it's decreasing. But one more scenario, what if it's coming, less than this minimum value? There can be scenario, right? So just assume the previous minimum was 2, like the smaller value was 2, and then in the initial case the my width would be 8, so area would be 16, right? So just assume this is the initial value, and now what if we are going to decrease the larger value, which is which was 7, right? So larger value was 7, if it's going to decrease by with the lesser value of this 2 as well, right? So in that scenario, let's say if you're going to decrease from 7 to 1, right, that could be one scenario. So what would be our height now? So our height would be min of this value 2, because I we are not going to change, and now this value from 7 it's going to be changed 1, and again the width is also going to change from 8 to 7, right? So now this value would be 1 and this would be 7, right? But this area was 16, right? So again we can see this area is decreasing. So now the conclusion is, if you are moving the smaller value inward, there is chances that area is increasing. But if you are moving larger value inward, our area is always decreasing, no matter now this larger value is going to be increased or decreased, right? Because area is nothing but what? Length into width. If you're going to move larger value inward, width is also decreasing. What about this length? Length was min of smaller comma larger values. So min of, if this value is, even if it's decreasing and less than this smaller value, and so there won't be change into this would be kind of again constant, and this, so the area will decrease. And if you're going to increase it, then again it won't matter and the area will again decrease. But if this is going to be lesser than this, then this value, like this constant, is also decreasing and this is also decreasing. So that's why this is going to, the entire area will be decreasing. So that was the crux of the problem. So our goal is like, anytime if you're going to move inward, make sure you are moving the smaller value inward. And that's how we are going to find the actual solution to us, or the maximum solution. So now quickly try to write the solution for this, if if you got the actual crux of the problem. So we'll be needing 2 pointers now here. So one will be starting from the start, and one we can start from the end of the array. Here is height dot length -1. Then we need one max variable. Let's initialize with 0, and then start traversing this array from start and end, right? So while I is less than j, now just go ahead and compute the area, right? So let call it length or height, whatever, right? So length would be what? Math dot min, whatever the minimum values of these two are, right? That is going to form the container, because apart, if you're going to be keeping the maximum number, the water will overflow, right? So our boundary is getting created from the min of those two. So height of I and height of j. What about width? So width would be j minus I. So now our current area would be length into width. And now if we just need to check if this area is greater than max area or not. So max area would be math dot max, whatever the current area we got and whatever the max area we had, right? So if it's going to be great, this current area is going to be greater than this max area, just go ahead and update the max area. That's it. And now then try to move the pointer inwards. So whichever the value is lower, just move that inwards. So if height of I is less than height of j, then move I pointer inwards, that is I plus plus, else move j pointer inwards, which is j minus minus. And once this loop is done, then the max area will be updated with the maximum area. Cool. Now let's go ahead and try to submit this. Line number 10, what is the issue? This value is not correct. Let's try to compile or run it. Line number 10 again. So now looks like every place we are good. Compile it. Yeah, accepted. Now submit it. Yeah, it got accepted. So yeah, that's all about the problem. So actual crux was, which one to move inward. So we know that, the smaller value is going to decide, whether we are going to get the maximum area or not. The larger value, even if it's getting, increase or decrease, that is going to decrease our area, because the area would be length into width, and width is always going to be decreases. In case of larger, what about the height? If you're increasing the height, right, that is not going to decide that. So our the smaller value will decide that, which will be again the constant, and the width is going to decrease, so area is going to decrease. What if this height is getting lower than this, the smaller value as well? In that scenario, your length is also getting decreased and the width is also getting decreased, so the area will always decrease as well. So anytime, whatever the smaller value is there, that is going to contribute to find, the maximum area. So that was the crux of problem. And the time and space complexity. Space time complexity is big of n, and in space we didn't use any extra space like, the area or something. So it's constant big of 1. That's about the problem.